Now, let's apply substitution to a definite integral. Remember, the term definite means an integral with limits, okay? So there is a subtle difference for definite integrals. So let me explain using another example, example 2. Okay? So for example number 2, let me take this example here. So let's integrate. So here's a part A. We're going to integrate between the limits 0 and 1, okay, 16x into x squared plus 5 to the power 3. So let's integrate 16x into x squared plus 5 to the power 3 between limits 0 and 1 using substitution. Now substitution is going to work here because if you take u to be x squared plus 5, okay, du over dx of x squared plus 5 is 2x, and 2x is related to the remaining term of your integral, so substitution does work. But there is an extra step that we need to do when you have an integral with limits. So I'll explain the extra step very soon, okay? So step 1 is the same as before. I'm going to choose my substitution u to be x squared plus 5. And in step 2, that is the same as before. Du by dx, I'm going to differentiate, that's 2x squared, 2x rather, okay? So du will be 2x dx. So let's have a stop and think. So a little black star for us to stop and think about it. So in our integral, I have 16x dx. Okay, so these are our remaining terms of our integral. Currently, I've got a 2x dx here. I need to get 16x dx. So to get the 16x dx, I can multiply both sides of this equation simply by 8. So if I multiply this equation throughout by 8, I'll have 8 du. That is equal to 8 times 2x dx. That is 16x dx. Okay, so 16x dx, 16x dx here. That's going to be replaced by an 8 du in our new integral. Now, this is our extra step, step number 3. Okay. Now, these limits, 1 and 0, these are the limits for x. Okay. We need the limits for our new terms, u and du. So let me show you how to calculate these new limits. Okay. So let me firstly show you how to work out the new lower limits. So bearing in mind, these are the limits for x, the x variables, okay? So 1 and 0 relates to the limits for the x variables, okay? I'm going to work out the new limits for the u variables. So for the new lower limit, let me show you how this is done. What you need to do is simply take your substitution, so u is x squared plus 5, so take your substitution, and to work out the new lower limit, take the old lower limit, so the old lower limit is x equals 0, and put that into your substitution. So u will be x, which is 0, squared plus 5, and 0 squared plus 5 is 5. So that is your new lower limit, okay? Likewise, similar step for the new upper limit. So for the new upper limit, take your substitution. U is x squared plus 5. Take your old upper limit. So the old upper limit is x equals 1. And put that into your substitution. So x is 1 squared plus 5. 1 squared plus 5, as you know, is 6. Okay? So this is the extra step that you need to do when working out an integral with limits using substitution. Okay? Now, the next step let's rewrite our integral. So let's apply substitution. So by substitution, so let's rewrite this integral. So 16x dx is 16x dx here. That can be replaced by 8. I'll write that 8 outside. Du, as always, inside your integral. Okay, so 16x and dx have been replaced. And what is remaining, I have an x squared plus 5. That I can replace by u to give me u to the power 3. Okay, and don't forget the new limits. New lower is 5, so 5 goes here. New upper is 6, 6 comes here. Okay, so what is left to be done is we need to integrate this using our new limits, and that will give us the final answer to the problem. So if we integrate this, keeping the 8 constant outside, we're going to integrate u cubed. It's u to the 4 divided by 4 using the basic integration rule between limits 6 and 5. If you substitute your limits, so remember, as with the basic integration rule, so remember, substitute your upper limit in first, then subtract, then replace your lower limit in later. So by doing that, I'll have an 8 into, upper limit is 6, 6 to the power 4 divided by 4, minus the 8. Lower limit is 5, so 5 to the power 4 divided by 4. And by doing this, you're going to get a final answer of 1342. So that will be the final answer to the overall problem that you have. Okay? So that is the extra step. Another way that you could do this is write your answer. So the answer, when you integrate 8 outside u cubed with respect to u, that is 8u to the 4 over 4 plus c. Okay, so if I take my red pen, so if you don't calculate these limits, there is another way. So back to this step, you're going to have 8u to the 4 over 4, add c, and 4 will cancel with 8 twice, giving you 2u to the 4 plus c. Then you can write this answer in terms of x. So if you replace the u by x squared plus 5 from here, okay, you're going to have 2 into x squared plus 5 to the 4, okay, plus c. And if you use, from here on, if you use your original limits for x, 1 and 0, apply them to this result here, you're going to get 1342 as well, okay? So the result should match. So let's take another example. So here is a part B. So in part B, so part B is, let's integrate between limits 1 and 4 of 1 plus root x to the power 5 over root x with respect to x. So let's go over this one. Now, in step number 1, now let's think about our substitution for u. Now, if I take u to be 1 plus root x, and when I differentiate 1 plus root x, okay, du over dx will be a half x to the minus half, okay? So let me put a little side calculation over here. So if you take u to be 1 plus root x, and root x is the same as x to the half, think about it, du over dx when you differentiate will be half x to the minus half, and x to the minus half is the same as 1 over root x, so you're going to have 1 over 2 root x here, okay? Now that term is related to the remaining term, 1 over root x they have in your integral, okay? So that indicates that substitution is going to work, and I'm going to take my u to be 1 plus root x, or x to the half in this case. Okay, so I'm going to go with this approach. So root x, remember, is x to the half. So in step number 2, du over dx, when I differentiate, that is half x to the minus half, which is the same as I've written here, 1 over 2 root x. Okay, so we need du, so we need du in terms of dx. So du will be 1 over 2 root x dx. So it's stop and think time. So if we go to our integral in question, I have 1 over root x dx, and over here I currently have 1 over 2 root x dx. So I need to make these match, so I need to get rid of this 2. So to get rid of the 2, straightforwardly, if I multiply both sides by 2, okay, 2 times du is 2 du, 2 times half is 1, so you're going to have a 1 over root x dx remaining, okay? So now I have a 1 over root x dx, which matches the 1 over root x dx in my integral, okay? So in other words, I can replace this by the 2 du, okay? Now I have limits, so I'm going to go with what I did earlier. I'm going to calculate my new limits for u, okay? But if you don't want to do that, you can just as well write your integral in terms of u and du, integrate that, write your answer in terms of x as we've discussed, and then use your original limits, okay? So either way is good, but I'm going to use the approach that I've used earlier, which is, so firstly, new lower limit. So remember the idea, take your substitution, u equals 1 plus root x, take your old lower limit is x equals 1, and put that in your substitution, so u will be 1 plus root x is 1, and 1 plus root 1 is 2. So 2 is your new lower limit, okay? Let's do the same to calculate the new upper limit. So u is 1 plus root x. The old upper limit is x equals 4. So if I replace x by 4 in my substitution, I'll get 1 plus root of x, which is 4. Root of 4 is 2. 2 plus the 1 is 3. So these are the new limits for our integral in terms of u. So now we're ready to go to step number 4. Let's go through the substitution process. So by substitution, okay, so let's rewrite this integral. 1 over root x dx is going to be replaced by a 2 du. 2, a constant, I'm going to write outside. Du, as always, goes inside. Okay, so these two terms I've replaced. Let's tick them. I've left with a 1 plus root x, and 1 plus root x is u, so I'm going to have u to the power of 5. Okay, so all of my terms have been replaced, but don't forget the limits. New lower, so new lower limit is 2, so 2 goes here. New upper is 3, 3 goes here. Okay, so let me continue alongside. So when we integrate, I'll have 2, let me keep that outside. Integration of u to the 5 is u to the 6 over 6 using a basic rule. Between limits 3 and 2. And if we replace these limits, remember, upper limit we replace first. So it's 2 into, okay, a 3 to the power 6. So let me use a larger square bracket. 3 to the power 6 divided by 6, okay, minus a 2 into, when I replace the lower limit, which is 2 to the 6 over 6. Okay, so I hope you can see that. Okay, so if you calculate this, you should have an answer to this of 665 over 3. So here is the methods to integrate an integral using substitution, but in particular using substitution with an integral with limits. Okay, so that ends that example and that ends the video as well. So I hope you enjoyed this video. If you did enjoy the video, a like will be very much appreciated, and I hope to see you soon. Thank you.